solve an equation that is quadratic in form by substitution. Let's see what type of equations we can use the substitution method for that. Here we have 2x to the power 4 plus 5x to the power 2 minus 12 equal to 0. If you look at these two variables, you see one of them is a square of the other one. So if I square this one, x to the power of 2, if I square this, I get this. All right, take a look at the second example here. If I square this term here, x plus 5, I get this one. I get x plus 5 squared. Look at this term here. If I square x to the power of 2 over 3, if I raise this to the power of 2, I get x to the power of 4 over 3. So when that happens, you make these substitutions. You let this middle term, x to the power of 2, the variables here, be equal to another variable. We'll just call it anything you want, u, w. In this case, we're going to call it u. So we let u be equal to this middle term, x to the power of 2. So if that's the case, if I'm going to let u be equal to x to the power of 2, if I square both sides, then u squared would be x to the power of 4. And that's exactly what we have here, x to the power of 4. So we can write this as 2u squared plus 5u minus 12. So what we're doing is we're forcing this to look like a second order equation by using the substitution method. This is the same example, another example here. I'm looking at this, I'm making the substitution, I'm going to let u be equal to this middle term here, x plus 5. All right, if I square both sides, u squared then would be equal to x plus 5 squared. And it's right here. So I can write this as 2u squared minus 7u plus 6 equal to 0. Once again, we are forcing this equation look like a second order equation. It's very important to get into the second order equation because now I can use the quadratic formula or factor this and solve for u. Once I've solved for u, I can put them back into my original assumption and solve for x instead of expanding this and make a mess out of this. Take a look at the next one. If I want to make the substitution, if I let u be equal to x to the power of 2 over 3, which is this middle term. If I square both sides, u squared then must be equal to x to the power of 2 over 3 raised to the power of 2, which is equal to what we have in the first term, x to the power of 4 thirds. Remember, this is 2 over 1 times 2 over 3. That's what we have here, right there. So this would be u squared minus 8u plus 16. Once again, I am forcing this equation, it doesn't look very familiar, to look like a second order equation so I know how to solve for them using the quadratic formula or factor them. So this is the first step to solve equations using substitution method. You have to see if these would be bright equations, first of all, because very selected problems can be solved by substitution method. We only can do that if these two terms are square of one another. If I square this term, if I get this term, then I can use the substitution method. If I square this term, if I get the first term, yes, I can use substitution method. So as this one, I look at x to the power of 2 thirds. If I square this and I get the other one, it means I can use the substitution method. Let's take a look at some examples. Solve each equation. We want to see if I can use substitution method here. Just by looking at this, I can see that I have this middle term x to the power of 2. If I square them, I get x to the power of 4. Yes, I can use the substitution method then. So I'm going to let u, or another variable, or w, be equal to this middle term, this variable here. So if I let u be equal to x to the power of 2, if I square both sides, then u squared must be equal to x to the power 4. So this would be 9u squared minus 37u plus 4 equal to 0. There it is. I made this equation look like a second order equation by using the substitution method. Well, everybody should know how to factor this. Now again, if you have a problem with factoring, I would suggest to go back and review the sessions on factoring that I have. So we get 9u minus 1 times u minus 4. We solve for u by letting each of these parentheses equal to 0. Now once I find u equal to 1 over 9 and 4, I have to go back and solve for x. I'll go back to my original assumptions. I assume that u is equal to x squared. So now we're saying that u is equal to 1 over 9. So we go back to our original assumption. So once I find u is equal to 1 over 9 and u is equal to 4, I'm going to go back and see what x is. We assume u is equal to x squared, right? So the two cases we have to check, right? We're saying that u is equal to 1 over 9 and also u is equal to 4. So let's try see what x is. So in this the first case, 1 over 9 must be equal to x squared, or 4, which says u is equal to x squared. So these are the two equations we have to solve for x, and that's what we're doing here. X squared is equal to 1 over 9, or x squared is equal to 4. So each of these can be solved easily by writing this as x is equal to, if I take a square root of both sides and put a plus and minus in front of that, then I can solve that. That would be x is equal to plus and minus square root of 1 over 9, or 1/3. And here I get x is equal to plus and minus square root of 4, which is x equal to plus and minus 2. So here we find 4 answers here. Plus and minus 4, plus and minus 2, and plus and minus 1/3. These are our solutions here, and that's what we did here. So we are using the substitution method to making this equation look like a second order equation, solve for u, and then going back and solve for x by substituting that into the original assumptions. Solve x to the power 4 minus 4x to the power of 2 equal to minus 2. We're going to use a substitution method here because we notice that x to the power of 2 here, if I raise this to the power of 2, I get x to the power of 4. When that happens, we can use substitution method. I'm going to let some variable like u equal to x to the power of 2, this term here. If I raise both of these sides to the power of 2, then u to the power of 2 then must be equal to x to the power of 4. So that's what I have. I have x to the power of 4 here. So I'm going to call this u squared. And here would be 4u plus 2 equal to 0. So I'm forcing this equation to look like a second order equation. I can solve this by quadratic formula, by identifying a, b, and c. These are the coefficient of x, coefficient of u squared, coefficient of u, and the constant. And then we substitute that into the formula. If you have a problem with quadratic formula, please refer to the session on solve by quadratic formula. You need to remember the formula: minus b plus and minus b squared minus 4ac square root of that over 2a. And we just simply substitute those values here, and we get 4 plus and minus 16 minus 8 would be 8 over 2. I can reduce 8 to 4 and 2. Part of 8 is perfectly squared, so it would be 2 radical 2 here. You'll notice that each term here is factor of 2, so I can divide each term by 2, or factor a 2 at the top of the fraction and reduce that with what we have at the bottom of the fraction. So you get u is equal to 2 plus and minus radical 2. Remember, we're not solving for u, we're solving for x. So then we have to go back to our original assumptions. Now I find u. Now I need to go back to my original assumption. I said u is equal to x squared. So I need to solve for x. There are two cases here. We're saying u is equal to 2 plus radical 2. Now we'll find also u is equal to 2 minus radical 2. So I need to go ahead and substitute that here. I get 2 plus radical 2 is equal to x squared. Solve for x here. Or second case would be 2 minus radical 2 is equal to x squared. Now here to solve for x, you need to take a square root of both sides. If you recall, if I have x squared is equal to k, x would be equal to plus and minus radical k. So here, if I take a square root of both sides and put the plus and minus, so this would be x would be equal to plus and minus square root of all these 2 plus radical 2. And this one the same way, so it would be x equal to plus and minus square root of 2 minus radical 2. So that's why we get these solutions here. We can write the solution set as plus and minus square root of 2 plus and minus radical 2. We get all those 4 solutions, right? We can write this as 1 here as a set. So we get 4 solutions here. Solving an equation that is quadratic in form by substitution method. Let's review the steps. Step number 1, define a temporary variable u, or you can call it anything you like, based on the relationship between the variable expressions in the given equation. So we want to make sure that these two terms here are square of one another when we make this kind of substitution. Substitute u in the original equation and rewrite the equation in the form, second order equation standard form. Step number 2, solve the quadratic equation either by factoring or using quadratic formula. Step number 3, replace u with the expression it defined in step number 1. So you have to go back and substitute the value of u into the original assumption. Solve the resulting equation for the original variable and check the answer. Solve this equation here for x. You notice that we have x plus 3 here, and then here we have x plus 3 squared. The first glance looks like we can expand this and distribute here and get them into the standard form, but that's a lot of work. Instead, we can use the substitution method because we can recognize that this term here, x plus 3 and x plus 3 squared are square of one another. So if I let some variable like u be equal to x plus 3, then if I square both sides, u squared must be equal to x plus 3 squared, which is right here. So this would be 5u squared plus 9u equal to 2. So you notice that using this variable, intermediate variable substitution method, I can make this equation look like a second order equation, a lot simpler equation to deal with. So in this case, I can write it in the standard form, and it looks like it's factorable. I can factor this. And those of you who have a problem with factoring, please refer to my factoring sessions. And then you set each of these parentheses equal to 0. You solve for u. I find u is equal to 1 over 5, u is equal to minus 2. Now I have to go back and solve for x, because you're not solving for u, you're solving for x. So you have to go back to this original assumption. We said u is equal to x plus 3. Okay, so if u is equal to x plus 3, there are two cases I have to check. If u is equal to 1 over 5, I'm going to put 1 over 5 here and solve for x. So I would say x plus 3 is equal to 1 over 5. 1 over 5, and then solve for x. I can subtract 3 from both sides of the equation. Here, I get x would be equal to 1 over 5 minus 3. Or, if u is equal to negative 2, then I plug it back in here again. So once I find these two values, I'll go back to my original assumptions. I said u is equal to x plus 3. The two cases I have to check. One would be when u is equal to 1 over 5. The other one would be when u is equal to minus 1/2. So the first case, 1 over 5 is equal to x plus 3. So if I go ahead and subtract 3 from both sides of the equation, I have to find the LCD, which is 5. I put 5 here and 5 over 5. So it would be minus 15 over 5. Then I have 1 over 5, so that gives me minus 14. Minus 14 over 5. That's how we get this answer. Minus 14 over 5. So in this other case, if I go ahead and let u be equal to minus 2 is equal to x plus 3. If I subtract 3 from both sides of the equation, I get minus 5. I get two answers, x equal to minus 5, which is right here. So this would be the solution set. Minus 5 minus 14 over 5. You can always check your answer by substituting these values into the original equation. See if it adds up to 2. Solve this equation for x. Okay, first glance, it looks like this term here, x to the power of 1/3. If I raise this to the power of 2, I get x to the power of 2 over 3 here. So when that happens, we can use substitution method. So if I let u, or some other variables, be equal to x to the power of 1/3, if I make this assumption, I'm going to say u is equal to x to the power of 1 over 3. Now if I raise both of these equations, both sides to the power of 2, if I raise this to the power of 2 and raise this to the power of 2, notice that I would get u squared. From here I get u squared then would be equal to x to the power of 2 over 3, which is right here. That's where it is. This is my u squared then. So my u squared here, and this is my u. That's what I'm assuming that's what it is. So you can make a substitution method once you find these two terms are square of one another. So I'm going to let this one, the smaller one, be equal to u. If I square this, I get this one, u squared. So instead of writing this, I would write it as 4u squared is equal to 3u plus 1. This is a lot easier to deal with. If I write this in standard form, I can factor them, that each of these is equal to 0, solve for u. Once you solve for u, you go back to your original assumption. So you're saying that u is equal to minus 1 over 4, u is equal to 1. I want to go back and write that u is equal to, remember u is equal to x to the power of 1/3. So there are two cases I have to check. I have to say, if u is equal to minus 1/4, what is x? If u is equal to 1, what is x? Put them back into this equation. Minus 1/4 is equal to x to the power of 1/3. To solve for x, I have to eliminate that 1 over 3. That's all I have to do is just raise both of the side of this equation to the power of 3. If I raise this to the power of 3, I raise this to the power of 3, then I can solve for x. This is how I get x. So x would be equal to minus 1 over 4 to the power of 3. And that's what we have here. X is equal to minus 1 over 4 to the power of 3, which is equal to minus 1 over 64. And also, we need to check one more condition. If u is equal to 1, then 1 is equal to x to the power of 1/3. If I raise both sides to the power of 3 again, then you can see we can solve for x. So in this case, again, x would be equal to 1 to the power of 3, or just simply 1. Minus 1 over 64, and 1 using the substitution method.